Just waiting for the live stream to start. Let's see if we can get it going. Okay, welcome everyone to zkWarsaw Meetup. And this is a series that we try to realize in a monthly meetup like this in Warsaw, focusing on zk, but also techniques such as MPC, FHE, TE. The format for these meetups is going to be a quick warm-up presentation. Today this is going to be a roughly half-hour presentation on risk zero. And then we will have our main speaker for tonight, Adam, one of the co-founders of Aleph Zero, who will be talking about modern design in private DEXs. Now, before we get to that, I'd like to extend our thanks to our partners, VLayer and the Ecosystem Support Program from ESP, from EF, and also to my co-founder Marek, Gosia, who is helping out with every meetup, and our video and photo crew. Other than that, I would like to remind everyone we will have a one-day conference this year as well, focused on these topics, called our other colleague mentioned it's called Verifiable Summit by zkWarsaw, and I should start getting the name right and be consistent with it. So it is VS by zkWarsaw, Verifiable Summit by zkWarsaw, and you can hope to get some goodies if you sign up using this pre-registration form here. Okay, other than that, let us hear about risk zero.
Okay, thank you for the introduction. My name is Tomasz Waszczyk. My background is software engineering and financial markets. Currently, I focus on building, mainly I focus on building the parachain in Substrate. Marek said that it's over-engineered. I can say I don't have so strong opinion. I do my best to...
Substrate, not your problem.
But my project is based on the Substrate, so by design is probably over-engineered, but I do believe that the stack technology makes sense. And what about today's presentation? Last time I was researching many zero-knowledge virtual machines, and one of the, in my opinion, the most promising stack technology virtual machine is risk zero. Have you ever heard about that?
Yeah.
Okay. So, so the presentation, I will do my best to make as short presentation as possible. I will show you the output of my research. Let's go. So, currently we have mainly two types of making VM circuit: direct one and virtual machine one. And the whole presentation will focus on the virtual machine, but that one is on the left side. It's a traditional way. How do we make? It's simplification, but more or less it works like that. And why I do think that, first of all, risk zero is promising, because one of the major advantage is that risk zero in the future, in theory, will allow to run any program in virtual machine. On the direct way how to implement circuit, zero knowledge circuit, it's not possible. So here we have some big advantage. Second one is hardware, and about the hardware I will explain later. So the goal, keep it simple, the goal. Goal is that every software engineer will be able to deliver, to deploy already written source code on the zero-knowledge virtual machine. That's the main promising of the RISC-0. And as far as I remember, I can say that today Rust is ready to production, even in experimental mode with STD library. But STD library is experimental mode, so be careful with that.
So do you know about the STD, how production ready that is?
How?
Yeah. Like what is missing? Why is it experimental?
The zero-knowledge virtual machine, first of all, also delivers formal verification. Marek said me that it's not important. I do think 5 years ago I was thinking that it's important. Today I think that it's important. And to deliver formal verification for the whole standard library, it's hard. It's not so obvious. Especially in Rust. And that's why I shared the information from my latest research, and it's written in the documentation. Be careful using that on the production. But be careful, but it's working. But we exactly don't know how.
I think they're doing audits right now. I think they're aiming to be on production this summer.
Maybe in 1.0 version.
Exactly.
Maybe in 1.0 version could be.
And they released 1.0 this week.
Last days, exactly last days. And I will show you some nice GIF from the release. But go to the presentation. First of all, what is zero-knowledge virtual machine? The whole architecture looks like this. It's simple. I was collecting my thoughts to draw that simple chart, and the copyrights are mine. And it's true. It's so simple. We have guest, host, and host works on the hardware. That's the generic of course it's oversimplification, but the general architecture looks like this. And one more thing, that the virtual machine is based on RISC-V architecture. And when I was asked to make this presentation, I also have some personal goal, and the goal will be now delivered. Who knows what is RISC-V? Oh, it's quite a lot. Okay. Here I have shown the.
Sorry, but can you say a few words about this RISC-V?
Yeah. Yeah, but later. I promise I will do it later. And here is the. I promise. Here is the GIF from the release 1.0, and here the most important thing is that block any Rust program. In the future, it could be any language. In Fiore works any language, but now it's Rust, and just like that. And it doesn't work. Okay. So what is RISC-V? What is RISC-V? RISC-V, it's a hardware connected with ISA. It's industry standard architecture, something like that. It's simply, in simple words, it's open hardware, open CPU unit. If you I wanted even to get more documentation, to get more specific documentation of the registers. It's hard, it's not so easy, but general version of registers, the link is in the reference of the application. But remember that RISC-V is just open source hardware CPU unit. And we'll say about it more. ISA instruction set. Here is on the GitHub. On the GitHub you can follow the development of the CPU unit. It's in China language. I can share internal information from the Chinese company that they promise to translate the documentation to English. But they promise, and if Chinese people promise something to do that, they will do that when they will have time. So it's not short time, but on GitHub you can follow that changes. I have said that I work on the Polkadot parachain, so I'm obliged to mention also that in Polkadot there is a strong vision to deliver new virtual machine called Polka VM, PVM, and that machine will work just like RISC-V. There will be reduction of registers, but still there will be, I think it's the first time in history that we build CPU unit as a software. It's not obvious and it's never happened in history. So I do recommend to at least to follow the development, because the development will have a lot of blood, I think. And here in the reference you can find the exact link. So here is a latest chart how the flow looks like. Here we have now Rust. Exactly speaking, it's LLVM, low-level virtual machine, or GCC. RISC-V via ISA. Then eventually could be some input, and then we built RISC-V circuit. So that's the circuit. Is not like genuine or generic. It's the circuit that is built on the CPU unit directly. And why Polkadot and why Chinese people do that? Because they wanted to have more faster virtual machine that works directly on the blockchain. And here I have written, I'm not sure even found or written, but here is a very nice one sentence. You can remember that one sentence, that Zero implements RISC-V. For me as a software engineer, I feel that we make history. Those development make history. If will be delivered. Currently it's not. A little bit about the proving. We have host, we have guest. Host emulates guest. Host sends data to guest. From the guest we have receipt. Then returns to eventually verifier, and we have receipt and verifier. Just it's not complicated. Verification on the virtual machine. We have journal. Journal is a place how to show a lot of logs, a lot of hashes if someone wants to understand more deeply, reset and seal. Generally speaking, it's easy. Here we have a lot of text. I don't know. I know that it's not good to write a lot of text, but let's write it. Here we have guest, host and guest. Host can emulates guest, sends any required data, handles the guest output, and guest executes the program. Do you follow? And to keep a little bit, even a little bit, presentation more attractive, I will show you a little bit of source code. Because I think the source code is just simple. When you see it on the front-end side, it's nothing complicated. So here we have the output structure.
Could you make the text larger? Control plus.
Enough? Here is just structure of output. The most important lines are here. Here we just handle in Rusty way. Let's keep it. It's just Rust. For me, it's hard, but just we proceed with data as a bytes. It's Rust. It's Rust. In Google, you will find it.
What do you parse it to? It says parse data.
Parse data.
Should be on the top. There should be some. So it's JSON.
It's JSON. The data are JSON. Yeah. Sorry for no introduction. The data is the introduction. The examples consist during the execution of the program. We will execute exactly that line. We will prove, and now I need to be specific as much as possible. We execute the proof that in data, I mean the JSON file, there is a field critical data, and I will check the value of that without revealing the whole JSON file. And that's it. I have JSON file, I know my critical data, and I prove in JSON without revealing the wall of the file that there is critical data. So I was thinking about that example a lot because it's kind of power. It's kind of power.
Like zkLogin basically does that, right? zkLogin takes all JSON and proves some content of it, including the verification.
But it's zkLogin. It's not in Rust.
Could be. It could be in Rust for many reasons. For example, because you mean in the browser you can compile. Yeah, okay. Well, you can compile to us. You can compile to us, but I don't think Aleph Zero works in the browser today. But you can prove it on the backend, probably. You just take the JSON from the browser and you pass it.
Yeah. Do you think does it make sense, that example? I'm proud from the example. I think that the example is pretty good. And now let's prove it. It's not so simple. It took me quite a lot of time to configure all of that. But now it's the presentation, so it should work. We will see.
What was complicated? What took time?
In Rust, everything is complicated, and a little bit those complicatedness I have included in the presentation. The worst parts.
We're gonna wait for the proving to finish.
Yeah, and I want
For a
to.
year and then we come inside.
The proving is hard. To prove is hard, and it takes quite a. Yeah. Okay.
How come but was it proved though? It was pretty fast.
Fast.
Proving involved
It took.
on your local machine. How many cores do you have?
Here, I think that 32.
Okay. Well, then it's a good
How
machine.
long does it take to verify it?
It's a start, right? It's a
Start.
Verify will take a long
But
time.
you can compress it to grow 16, but that will probably at least double the proving time.
28 gigs of RAM.
Come again?
128 gigs to convert star into graph 16.
Exactly.
Yeah, so it's a lot. I didn't get 120 what?
28. 128
Memory
gigs
required.
of
100.
gigabytes of RAM.
Ah, okay.
1 to 8 gigarams of RAM.
And if you don't convert, how long does it
Yeah,
take now?
but that you can do on the server because
Yeah.
it's already executed.
Yeah, this is already privacy, right? And then you do whatever.
And we have prover markets now.
Yeah.
Well, we trust
Do we?
the server.
Yeah, and
Conversion.
so
Because
it works.
Start. Start is kind of expensive to verify on chip. So if you want to verify on chip, you compress start to snap, grow 16, but that kind of doubles in price.
And now quiz time.
Nice.
Quiz time. The question is, that source code, where is executed from the point of the architecture? I have drawn that so nice architecture not by accident.
Compiles to RISC-V and then executes it, right? The host. In the host machine, right? Host machine?
But
Oh.
it's guessed.
Oh, guess.
But where is the guest executed? Inside host.
On top. From the point of view
If you
architecture.
shuffle words long enough, it's on inside on top.
No. So there is no winner. Because now.
Drive goes to the speaker.
No, I need to. Okay, so go to the presentation. Go to the presentation, and I will think about the next question. And now I want to, because my goal is also to show you my practical experiences with that, and it's pain. Generally, it's pain. And you have said how time-consuming is to create simple proof, and it's not acceptable for more advanced. And Aleph Zero delivers something like Bonsai. Bonsai is a service. In theory, it helps you to export that complicated work to some external server, and they will do that for you more easily. It's theory. Currently, it's theory, and there are limits, but you can use it. But Yeah. Okay. So good that I have switched in proper way the slides. But here is my mainly four pains. First of all, don't ask me why. Cargo install, cargo B install requires very solid network. I don't know why. On Wi-Fi, I have strong Wi-Fi. It doesn't work. Maybe my environment is something. Have solid hardware, and that line. When you work with Bonsai, you also need to follow proper toolchain. And for now, the trick is that I personally know some guy from the Bonsai, and they shuffle the versions internally, even internally, and deploy randomly. Okay, it's funny, but if your job is to deliver something, it's not so funny. and my input, and if you are going to work with that, you have to verify the toolchain, exactly which toolchain works on the Bonsai. And as a proof that the situation is, here is the proof. And it's only one proof, because it's frustrating. We can smile, but if you are under time pressure, if some general or some sergeant says that you need to do that, and you have Bonsai, but Bonsai have different toolchain, and you met some guy that works from the work in the Bonsai, and you ask him, what you using now? I don't know. But we was trying, it's a quote, we was trying to downgrade, but was better to, we were trying to upgrade, but we downgraded. So follow, and you can write that issue, and there is many kind of that issue, because it's frustrating. So seriously, you need to have on your own hardware, because when you have own hardware, you have the whole environment, and you know what you do.
I'm not sure everything they have on Bonsai is open source though.
No,
I think compression to Groove 16 is not open source.
it's not open source.
Your own hardware doesn't really solve
Yeah.
the problem.
Mm-hmm. Yeah. And then generally the Bonsai, as far as I know, it's going to be just business model.
I heard a rumor they actually want to go for prover network. I don't know if it's true.
Doesn't it say you have the choice of generating proofs on your hardware or delegating?
Yes.
So you can't compress with the
yes,
snark
but
or with
it's not as well optimized as on Bonsai, and there are some elements that make a compression from those.
Oh.
Yeah. But on the other hand, let's say SP1 has an open source Groove 16 prover that you can verify with Gągol and smart contract.
Yeah.
Okay.
But now,
Sorry, but if you delegate this proving to somewhere else, you have some guarantees that this somewhere else does not know your secret inputs, or it's like some cryptographic stuff, or this is some.
It's about succinctness, not privacy or zero knowledge.
The proving is split into two parts, right? There is a proving of Stark, but Stark is expensive to prove on-chain. So oftentimes what happens is after you generate Stark proof, you compress it into Snark proof.
Yeah.
So the second part already preserve privacy, so you can
Okay.
only the second part can be done in prover network. the thing is, I don't think Bonsai today is kind of supporting.
It's same for SP1 actually. SP1 also does expose the interface for this.
I think they have open. The Grok 16 compression is open source.
Yeah, but the thing is, but like I'm talking about library. Library doesn't expose this, so you need to hack it yourself. But it's doable.
So both ways it's extra steps, but in theory it's possible.
But I'm wrong that when I say that exactly I don't know, I do not know how Bonsai works, because I just the endpoint, and so in my opinion, according to my knowledge, it's not for sure, it's not trustless. There is, I think, some.
No, it's trustless.
It's
But
trustless?
you can leak private information to do zk proof.
Yeah.
If you're only for such simples, then it's fine.
Well, you can verify the zk key yourself.
Yeah.
So in particular, can you verify that the prover did it?
Mhm. But it's very good question.
Oh, thank you so much.
Oh.
We have winner.
Oh my gosh.
What is it?
It's like a ledger. Actually, me and Shafia, we were trying to do something on this, so maybe it will be used. So thank you so much.
Make sure it was used before with some customers.
But don't trust fully. That's the good rule.
Put some money.
Okay, so let's remember that for now Rust app override 177 it works, and the proof is on my machine. Okay, so I think that everyone more or less knows what is RISC Zero virtual machine, and now someone asked about the RISC-V. There is a lot of noise in China about the RISC-V, and around 2 or 3 years ago, officially China push agenda, push money, push actions on the mass adoption of the RISC-V in interior of China, but also in countries that rely on China. We make history here. They don't want Intel, they push RISC-V. It's first time in history, I think, we have this kind of situation, and in search engine you will find a lot of information. And if you know Chinese language, you will find more of that.
So this is why you choose it over some competitive architectures, like
There is no competitive architectures. That's the only thing.
okay.
There is only one open source, but in China there is. When you will interested in about the topic, you will find that there is a lot of Chinese companies that get the topic, the RISC-V, and work on own implementation to make faster registers, faster executions of the hardware, open hardware. And when I do some presentation, I do like to share some interesting book, and the book is Cheap War. I do recommend that book. I do really recommend that book. During the presentation, I was trying to tell you that at least if you are a software engineer or something similar, you should follow the RISC Zero development. I think the RISC Zero implements RISC-V. That sentence you can remember, because it encapsulates a lot of data in a very nice way, in my opinion. And when you will read that book, you can get impression that in front of us, or maybe we are already in the development, in the environment where it started weaponization of hardware, and weaponization of software also. It's an umbrella term, but I do recommend that book. And I can say that probably we can new kind of war. And completely new type of war, but war has always the same output. And I feel obliged to shield Polkadot Decoded 2024. If you are going to be there, probably you are going to be. Yeah, exactly. But if you are interested in to meet people from the dot ecosystem, I feel that you should be there. Here I have miscellaneous references. Most of the links that I have was using to prepare the presentation. I do recommend cooperation final. I do recommend to read it to get the vibe how people coordinate in the context of nature and in the context of the previous slide. It's serious. And game theory about life. It's kind of painful, but I think that everyone should watch the video. Yeah, and how China is building an open national chip plan, so I was saying about that. And there is a lot of knowledge to get to more understand the environment we live in already. And terminology of risk zero is also interested in. Last bit, in the age of digital platforms, your duty is to offer value proposition. If you are free, it's not enough. The rules in the age of the digital platforms like Bitcoin, Ethereum, DOT, and so on and so forth has changed for software engineers significantly. Don't hate me for that. For conclusions, if you will have some, I don't make the rules. Thank you.
Thanks so much. Adam, are you ready? Łukasz, czy mikrofon przekładamy?
Tak, zlecam.
There is a question.
Have you heard about Cairo while doing your research? And don't you think it's like better prepared for the zkWarsaw? Because this Zero architecture is designed to be fast as a CPU, but
Exactly.
it's very slow in zkWarsaw. And so I think that Cairo and KRBM might be a better choice for
Exactly, you are right. And the first version of the PDF here is going to be much simpler. But in the future, currently, as far as I remember, BVM wants to implement 30 registers. It will be very slow. But we want to make the field to implement the wall. And then currently you are right, and I don't have the second ledger for you because it's a very good point. But the goal is to make PVM much faster than Cairo, but in the future.
Cairo is also like development, so
It's work.
okay.
It's
Dziękuję, dziękuję.
it's very good fun, but I don't have the second. But
No worries.
thank you for
I tak, HDMI. Aha. To... Tak, to... Żeby nie było, że coś tu wpinam, to tylko zabrałem HDMI. Masz też dongla do... Tak, tylko masz tam dwie rzeczy wpięte, nie wiem, która to jest od tego akurat. Nie wiem. Nie, tak? A, okej. Dziękuję, nie potrzebuję. Tak, to na pewno potrzebuję. Dzięki. Perfect. Am I audible? Do I actually need this microphone?
Yeah, it works.
Oh, and it's...
For the live stream.
Oh, okay.
For the live stream.
Okay, for all our viewers online. All right, so thanks for having me here. I'm Adam from Aleph Zero, and I'm going to be talking not about Aleph Zero really, more about the general space of private exchanges and the ideas that are, let's say, explored by modern projects. The vast majority of them are not actually working yet or not deployed, but this is definitely something that we'll be seeing in the next couple of years, let's say. So I'm gonna start from sketching some kind of like a framework or like a way I like to think about it. So what does it even mean to have a private exchange? So or maybe even one step back. What does it mean to be anonymous? So generally, I assume everyone knows here what is zk and how zk proofs, maybe not how, but what do they do? How they work is way harder than what do they do. Like the general framework, what we usually think about when talking about zk privacy is roughly this. So there is some guy, let's say this is us, and well, let's say that according to the protocol, we have rights to withdraw some tokens of type A from the system, like whatever the system is. So what we do is we generate the proof, then there is some verifier, like on-chain, maybe somehow off-chain, and which aggregates their ideas for off-chain aggregation of proofs. So there is some verifier that verifies that, yeah, what we are proving is correct. And then the system usually keeps all of the deposits in one place. Well, because there is no reason to not do that. I mean, like it does the accounting using zk, so it does not need to separate funds of one user from funds of the other user. They are actually sitting in one pool, and like all the accounting is done, well, in this tricky prover verifier manner. So it's not possible to infer, looking at the chain, how many funds each user owns, or like generally, is there a whale there? Even these questions are not possible to answer. So the protocol, like originally this protocol is, I mean, not this protocol, the protocol which is doing that is called ZeroCoin, and basically it was developed for Zcash, and then in many additional instantiations, we've seen it in Tornado Cash, Tornado Cash Nova, Railgun, Penumbra. We're also using protocol like that. And I think I could say that there is no other protocol for private token exchange. I mean, like, literally, this is the only protocol that we know as a civilization. Of course, there are some upgrades for speed and stuff like that, but generally the framework stays the same.
Who is it from? ZeroCoin?
ZeroCoin is from Zcash. I mean, the authors of the paper is definitely Matthew Green is one of them. I don't remember the other, probably. Generally, I think most of them have been involved with Zcash at some point. I know that most of them are not anymore, but yeah. So I'm gonna use the name Shielder, which is, I don't think it's an official name for it. I like it because it's simple and like it captures that like there is the same primitive which appears in many different places. So now, like, what does it mean to have private DEX? I'm gonna draw a line between privacy and anonymity here. So first, let's talk about anonymous exchange. So what does it mean to have anonymous DEX? So, well, this is actually pretty simple, much more simple than you could think, perhaps. So what the only thing you need is to have a proper implementation of Shielder, which you are using before you use Uniswap. So on Ethereum, for example, Railgun is such a proper implementation. Tornado Cash Nova is also a proper implementation, although for various reasons is somewhat, let's say, more problematic.
Less popular.
Yes. That's true. So how does it work then? So there is this user. User sends X tokens A. Well, it's the intent. User wants to send X tokens A to Uniswap to get some tokens B. What he does instead is it sends them to the Shielder, and then from the Shielder it initiates the action at the Uniswap to get the tokens back. Now, like, very small caveat, because actually, like, I'm not gonna dig too deep into it, but like, if you know how this stuff, this zero coin protocol works, is actually that there is this concept of a node, which is UTXO, which user can create for himself, and only the user knows about its contents. So it's definitely not possible for Uniswap to create UTXO for me. So how actually this interaction works is that we are depositing funds to the Shielder, then from the Shielder we initiate the trade at Uniswap, then the tokens which are getting out of the Uniswap are landing at one-time account, and only then we get them back to the Shielder. So of course, like, this can be hidden under frontend, so like user does not need to be exposed to this pattern. User should not be exposed to this pattern, but like for the technical reasons it needs to happen like that. Yeah.
So is the one-time account the node?
The one-time account is the node is the concept which sits inside of the Shielder, and the node is basically a private UTXO, where inside you have the token type, how many of the tokens are in the node.
Node, okay, gotcha. And what do you mean by Uniswap's UTXOs? Aren't we talking accounts?
No, I mean, so Shielder operates with UTXOs. There are these nodes. And of course, Ethereum does not operate with UTXO. So UTXO is an internal concept inside of the Shielder, because the only private transfer protocol that we know operates on UTXOs.
So these nodes are basically pre-images for nullifiers, right?
Yes, not only nullifiers, but generally yes. Right, so there is one more caveat here, which is that, well, if we do it exactly like that, so like, let's say we send 1.2 ETH to the Shielder, then immediately we go out of the Shielder to the Uniswap, like, it wouldn't be too hard to track us. So it's much better to think about the Shielder as a wallet. Basically, it's not a place where you would like to mix your tokens, it's the place where you would like to keep your tokens, like at all times. There is no reason to store them anywhere else but the Shielder.
And Shielder has like its off-chain and on-chain part, right? When we like, okay, so it's like we have a contract and we have a remote contract controlled by some off-chain logic.
I mean,
layer to preserve.
Yes, I mean, the first thing is that we do need to have some secrets. Like, we as users need to store some secrets. Actually, like, if you do it in a clever way, you can basically store only the seed and derive all the remaining secrets based on the seed. And yes, there is a need for the relayer, otherwise the UX would be absolutely terrible. So there are other guys which are paying for the gas, basically. Yeah. Right, so this is how anonymous DEX roughly works. So, like, yeah, I mean, this is not the end of a presentation. There's some more content. So, natural question is like, okay, that sounds pretty good. So, what else could we want possibly from this whole privacy thing? Like one of the things that is often discussed in the context of privacy is MEV protection, or like front-running protection, let's say. So, like, if we would be able to perform private trades in some magical way, well, it seems it would be pretty hard to front-run us. I mean, like, if no one can see what we're doing, I mean, like, that's the argument. I hope it's self-explanatory.
Sorry, but you say that this anonymity gives you MEV protection?
No.
No.
This is like, what else could we possibly want? Like, what is not here? Like, from like, what stronger flavors of privacy would we possibly want? So, like, MEV protection is one. Anti-spoofing, like, if we would have markets with private orders, I mean, this is kind of iffy, but this solves the problem of people putting orders just for the sake of scaring markets. This is not, I don't think this is a big problem in crypto right now, at least not on chain, because order books are not very popular, and this is like exclusively order book problem.
What do you mean by anti-spoofing?
So, spoofing generally is a practice in the order book where a whale puts a massive order just to scare the market without the intent of this order to be ever filled. So, like, if you have a private markets, like, this practice is just not possible.
Never feel order.
Yeah, I mean, then, kind of related, but maybe the other side of the same coin, decrease market impact of posting an order. I mean, if we post a massive order, generally, like, even before it starts trading, the market reacts. So generally, this is known as optimal execution problem. I mean, like, let's say we are a user and we want to trade, I don't know, $10 million worth of not ETH, but some a bit more exotic token. Like, the question how to actually, I mean, obviously we're gonna impact the market with this trade. Like, how to do it to impact it as little as possible, or to get in, like, cumulatively as good price as possible. So, like, this is something that we would possibly want from private trading. To not reveal the entire intent at once, but rather make it somehow more sneaky. And oh yeah, it's actually the next point. So generally, this is what I'll be talking about, and yeah, I think we can get going. I had one thought here, which no, let's go. Right? So,
Shield there works on UTXO, right?
I mean, internally, yes, but I highly recommend to think about it in like a black box fashion. I mean, yes, internally it uses UTXO, but you can forget about it, because we're not gonna go in depth into that anymore during today's presentation.
That's a big question if I ask. Uniswap works on the model
Account model, yes. Everything else works. I mean, like, this is kind of like, this is the boundary. Like, like, everything here is account based. Inside we have UTXO, and like here we make a translation here and translation here again.
So environment is based on the account model.
Yes, like every reasonable blockchain. And I stand by this opinion. Yeah, let's, again, highly recommend to think about it in a black box fashion, at least for this presentation. Impossibly private IMM. So there will be few things which seems natural and are actually not possible that I'm going to discuss. First is this, this kind of first thought that you may have when thinking like, okay, let's make a private Uniswap. So let's say that there is some magic thing called private swap. Like we deploy a private swap, which is just like Uniswap, but everything happens in private, like first because of some cryptography. Like let's say that we have it.
Even the price is like
That's a great question. Very good question. I would give you a gift if I would have gift. Right. So this is basically the problem. I mean, at least one of the problems. The other is that if we would have this kind of a private AMM, let's forget about how it's built. Let's just think that okay, there is this magical cryptographic thingy which works as AMM but is private. Then first thing is, well, we don't really know what price to expect, right? Because well, either it tells us the price, and then we can just basically see how the price is changing and infer what trades are being done inside, or well, or it does not tell us the price, which is absolutely horrible experience, because then we do the trade and well, we learn the price anyway, but like we learn it the hard way, right? Like we trade and then we're happy or we're not happy. So actually, like one of the things is that if we would create it, it would be not so hard to actually reveal what's happening inside by creating the trades. And the other thing is that, like, from the economical standpoint, this does not make so much sense, because we do want the price inside to actually reflect the market price. Otherwise, it's not actually useful. Well, it's not a useful tool. If we have a DEX which price does not reflect the market price, then it's useless, basically. So yes, that's problematic. So like the lesson we should take from it is that yes, we do want DEX to be somewhat private, but we definitely do want some information to leak eventually somewhere, or I don't know. Like it's not that obvious that we want to put everything in private. At least for AMM. Like maybe that's the distinction I should do. So in crypto there are two flavors of DEXs, or like actually mostly one, but like possibly there will be another one. I know at least two nice projects working on it. So the first one is AMM, which is kind of like it offers only instant trades. I mean, in economy, I think the word trade stands for instant trade, but like it offers just the instant trading where we send tokens and we, in the very same moment, get some tokens back. And usually, like how general markets operate, is that there are limit orders. So we say we want to sell this amount of this for this price. And it's usually not filled like immediately. We can put this order and it's gonna be standing and waiting there until someone else decides to buy the same amount of the same thing for the same or better price. So this impossibility kind of works for AMMs. Because in order books, it wouldn't be such a big problem if the price would be different. Like it's okay. I have a different slide about impossibly private order book. Yeah, that's the comment that it works for AMMs. That's the slide. But this impossibility is, I mean, this would make sense. It's not impossible. It's impossible cryptographically, at least for now, at this point in time that we're right now. So let's say, how would we imagine this private order book? So, well, ideally, it would work in a way where, like, let's say, Alice wants to sell X tokens A for B at price P, and Bob, like, there is this amazing coincidence that Bob wants to buy X tokens A for the same price. So what they do, they put this encrypted orders to some magical private matching algorithm, and then this magical private matching algorithm does everything for them. I mean, it interacts with Shielder and just basically swaps the tokens, and Bob gets Y tokens B, and Alice gets X tokens A. No one learns anything about what just happened. So then the question is like, what's this private magic? So usually for things like that, you would want multi-party computation. Because, I mean, there are, I think, four kinds of private computation. One is zk snarks, which are not even on this list. So why we can't do that with zk snarks? Because this is the computation with two private inputs coming from two parties. So there is no single party which knows all the inputs. So like zk snarks basically work only when there is the prover, the single guy who knows all the inputs. Actually, I just realized that there is a paper of Ozdemir and Bonnet for collaborative snarks, but that does not apply. I mean, of course, like cryptography is a wide area. Generally, zk snarks are not enough. I mean, what we want is the situation we're in is where there are multiple parties with their own inputs, and we want to have a result of the computation based on all these inputs without revealing inputs between the parties. That's basically the definition of multi-party computation. So why don't we just do it with multi-party computation? Well, it's computationally infeasible. Basically, MPC works in a way where a single multiplication takes usually, I guess, something like 2 to 3 rounds of communication, so probably something like half a second. And even one inequality, it's logarithmic, requires logarithmic number of multiplications in terms of the size of the input. So like single matching of two values would take several seconds. If we have like big number, I mean, if we would want this order book to actually reasonably work, probably it should operate with private matchings of thousands of orders or tens of thousands. So like tens of thousands where each is encrypted, so we cannot sort them. We just need to match each to each. Like that sounds horrible because like each matching is gonna take a couple of seconds. So like 10,000 squared when it comes to the pairs, like no, it's just not gonna work. TE, well, yeah, I mean, let's say that there is a scientific debate regarding TE security. What I meant here is that I think it's possibly considered insecure in the paradigm where we want to have a secret which is persisting for a longer period. I know that there are very good projects which are using TE for short living secrets. In order book, like when we have a private order, it should remain secret for possibly months. Fully homomorphic encryption, like that's just, I mean, there is no simple way to actually apply it. I mean, there are questions, okay, so is fully homomorphic encryption, so who holds the key, or like, it's just not really working. So that's, maybe it's not impossible, it's infeasible design for the cryptographic reasons. So like that's why no one is actually promising that right now, even though various projects are over-promising many things.
Do you happen to know if it's actually a use case that orders are standing for months rather than minutes or days?
That's a good question. So, like, my take on that would be that crypto markets differ from traditional markets in many reasons, and one important is that there is this not your key, not your coin kind of, let's say, way of thinking, which I think makes these markets, I mean, in traditional markets there are no non-professional traders trading big amounts. Like every big trading happens with bots and basically professional agents. In crypto, there are whales which are still trading manually, which means that they're not even always online, and they may have the, let's say, setup which require, for example, it may be air-gapped setup for big accounts. So basically, there is, at least that's my understanding, a need for a way to, for a trader who does an operation maybe every day, single operation, to effectively trade. So, like, for that reason, I would say that possibly yes. Maybe not, I don't know whether it's months, but days or weeks, yes, I think so. but it's like I had like a let's say 80% certainty that this is the case. I mean, we talked with we did some research. We talked with institutional grade investors, and some of them have been using I would say surprisingly non-sophisticated investment methods. Like despite operating with very big funds sometimes. So that's basically how I see it. That's like regarding our take on it. Like what we want is we want to offer close to optimal execution for manual traders. That's like, and that's where you would want something to remain private for a prolonged period. Okay, so there are some ways around these problems that I just discussed. So I'm gonna use the shielder primitive as implied. I mean, otherwise I would need to put the shielder on every slide. Like basically, all the users keep all the funds in the at some shielders at all times. That's gonna be implied. So one way around it is to introduce some privileged actors. Relayers. I mean, like they're gonna relay some intents, let's say. So let's call them relayer. So now we have the same situation on the slide before. Where various parties are posting their, like this is the very hype word right now, intent. So they are posting their intents to these relayers. So let's say Alice trusts this particular relayer and Bob trusts some other relayer. So this relayer learns about the intent that Alice has. So this relayer knows how many tokens of which kind Alice wants to sell for each price. The same goes for Bob and his trusted relayer. Additionally, like I'm not gonna go into that cryptographically, but there is a not so complicated, let's say, way for them to allow these relayers to fill these intents without giving them rights to steal the tokens. So like literally the only thing they can do is to actually fill this order. Then the relayers are doing two-party computations to match the orders. So like there is some cloud of relayers, maybe dozens of them, and they are just randomly matching and running the same protocol to see whether there is anything to be traded between the two parties. And well, and if that's the case, they trade it. So now, natural question is, okay, so we just said that multi-party computation is infeasible, and now they are doing multi-party computation. So, like, why is it easier? So, well, there is a reason for that, actually. So this relayer, like, actually knows the plain text for all the orders it holds, and the same goes for the other one. So they can just sort it, and then, like, if they have sorted orders sorted by the price, they can just say to each other, okay, so like the cheapest I can sell you is this, and the other will say, well, that's actually good because that's still better than the worst by order that I have. Of course, they don't do it this way because that would be too revealing. But basically, this is a version of Yao millionaire's problem, which is the problem where there are two parties holding a single number, and they just want to know which of them holds the bigger number. So they use something like that, and this is the first multi-party protocol known, I think, the Yao millionaire's problem. Like this was the first problem posed, which like the story was that these are two rich men, and none of them wants to reveal the wealth, but they want to know which of them is the richer one. So yeah, it's solved already by Yao. And yeah, like version of it. I mean, Honestly, I don't even know the reduction from YAO to this protocol, but like it seems to me intuitively it seems similar enough for me to believe that yeah, this is way simpler than the previous case where you actually need to match each order to each because you cannot sort them because no one sees insides.
Do you have an intuition for YAO?
How is it solved? Yes, I mean like there is this concept called garbled circuits, and the intuition is that basically in two-party protocols they are not symmetrical. I think never, because like basically always there is the case there are two parties with these inputs and they want to learn the common output. Like the protocol basically will be I'm sending this guy and this guy is sending something to me. So like eventually one of them will learn the output first. So like this will be unsymmetrical. So in this protocol they have roles assigned, and roughly it goes in a way where for intuition goes for simpler protocol on the Boolean function. So like me as a garbler, I'm listing all possible evaluations for all possible inputs, and I'm cleverly encrypting them with different keys. And I'm sending you all of these encryptions. And then you, even more cleverly, extract the specific keys from me that are required to decrypt only the evaluation that we want to compute. This more clever extraction is called oblivious transfer. And
That's what I thought it's going to be obvious transfer. But it's had to be some kind of weak variant of obvious transfer.
I mean, basically it works usually with the reductions where you, like whatever you want to compute, you draw it as a circuit and you go gate by gate, similarly to snarks. With these garbled things, still you can do only one round of communication. You just do the reasoning gate by gate. Okay. Right. This is the kind of caveat, but this is also roughly the design of Renegade Finance or Renegade Phi. So I'm not even sure whether this is exactly their pitch, but generally this sounds like a very good protocol for trading exotic tokens, where even the fact that someone is selling this token can impact the market in a bad way. So like this is generally protocol for optimal execution of big trades or like big enough to influence the market of the given asset.
How many relayers would be required to be good enough, private enough?
That's a great question. Of course, there is no answer for that. What I can say is that, like, what they promise is that you can be your own relayer if you are okay with being online at all times. I mean, you can download the software yourself, and then, well, it scales. It scales linearly with a number of relayers because each relayer needs to talk to the other relayer, and then. Like this is the very simple version, which I don't think we're gonna ever deploy, because then I could just spawn 5,000 relayers just for the sake of destroying the network. So, like, probably there will be some more clever way of, or maybe some, I don't know, some more clever way of choosing the relayers to run this protocol. Maybe some reputation system, or I don't know.
Isn't it exponential though? Don't the relayers all need to exchange with one another? It's squared, right?
I mean, it depends what question you're asking. I mean, like from the perspective of a single user, I have a trade and I want it to be filled. Well, to be sure that, I mean, the worst case is that my relayer will need to talk with every other relayer. So, like, I guess it's from some perspective it's linear.
And here, do you think it can be made in a way that you don't need to trust a single relayer, in the sense that you start with sharing some information with a few relayers, and then they would proceed?
I mean, well, definitely you can share all your information with more than one layer, but this makes it weaker when it comes to privacy. But when
Secret share, right?
well, that's a very good question. I don't think that there is a simple protocol for that. I mean, you could imagine kind of like a decentralized relayer, right? Like where like inside of the relayer there are actually several guys, but then you have MPC inside of MPC. I mean, like these guys need to run MPC protocol to run another two-party computation protocol. That sounds prohibitively expensive. I mean, one of the things they would need to do is sorting. I mean, they get the secrets, and to even start talking with other relayers, they need to sort their own secrets, which already is a big task.
It must be done in a way that you kind of do this big MPC among everyone, not like you start with doing the MPC inside and then sharing the
I mean, honestly, I don't think it's possible. I mean, like generally this design of Renegade, it's a nice trick to go around the thing that I shown on the previous slide, where you actually needed this quadratic number of complex operations. Like, is there a middle ground, something between that one and this one? I don't know, and I'm pretty sure guys from Renegade does not know either, and they've spent some time thinking about it. So I don't think there is a simple answer. I mean, a simple positive answer for your question. Okay, and I mean, on the next slide I have another design. So if there are additional questions, shoot, and otherwise, yeah. Another idea is to reveal something on trade. So this is this will be targeting different cases. I mean, yeah, I guess different part of the market. So how would we go about revealing on trade? So now we have this thing called aggregator, which batches them, opens them, and then proceeds with the trade. So importantly, these orders are batched in private. So this is some homomorphic encryption going on here. Not fully homomorphic. I mean, the only thing we need to do is addition. So LGAMAL, for example, does the job. And this is what is actually used, LGAMAL encryption for additively homomorphic. There is a protocol called Saver. I mean, I don't think it's super popular, so if anyone's interested, you can just Google for it. Basically, what it allows you to do is, whenever you're generally generating Graph 16 proof, you can also very cheaply generate LGAMAL encryption of part of the witness, which is exactly what you need, because you're in the shielder with all your funds, and then you generate the proof that, well, you have a right to spend these funds, and also, very cheaply, you generate the encryption of the amount that you want to trade. I mean, the paper describes Graph 16. I mean, it's possible to generalize into Plonk and yeah, probably other systems as well. So what happens here economically is these orders are private. Aggregator is any party which, I mean, you can aggregate them private, and then you need someone to be able to decrypt them. I mean, like, if there is encryption, there's always this natural question, all right, so who holds the key for this encryption? So there is some party outside, or maybe this actually can be a committee, and this committee will decrypt the aggregates only. So people are submitting encrypted orders, they're aggregated, the aggregate is opened, and then it is sent to some open exchange protocol. I mean, this can be basically anything. It can be sent to Uniswap, it can be AMM. It can basically become an order just to be filled by someone. It can be a Dutch auction, because why not? It's also a means of trading. So the projects doing that is Penumbra from the well-known ones. Also, there is a paper on common which we wrote with Michał, and it also describes a very similar approach, although Penumbra is using concentrated liquidity AMM, which is like kind of like Uniswap v3 for this open exchange protocol. In the paper, we described Dutch auction as this protocol. So why does it make sense? Or maybe economically, what does it achieve? That's not a trivial question. So, well, it reveals on execution, which is nice because it prohibits front running. I mean, everything remains encrypted just to the very moment where it's time to get executed. So, like, there is no way for someone to get before this trade. Basically, this is one of the key, let's say, design goals. The other is that it does help with optimal execution to some extent, at least. I mean, your order may be waiting until the batch is created, and then inside of a batch, it possibly will be matched against other orders from other users. There is one important problem with this design, which is somewhat technical, but I'll try to give my best to explain it. So generally, like, let's say for the sake of simplicity, let's say that here there is just Uniswap, just AMM. So normally, if you are trading on AMM, there is this concept of tolerance, which is like when I'm sending my tokens, I don't want. I mean, I have some limits to which I accept front running me. I mean, like, if someone just brutally front runs me, I prefer my trade to fail rather than to actually trade on such a bad price. So this is called the tolerance. It's usually like, I don't know, we can set it for 0.5% or 1%. The problem is that, like, the price that we see at the moment of creating a trade, it's not necessarily the same price that's going to be there after our trade reaches the Uniswap. And if we are doing a big trade, it's surely not going to be the same price because someone will notice the trade and just get before us for profit. So, so the problem here is that due to the aggregation, there is no way to allow user-specific tolerance because, like, we have encryptions here, which we are the only thing we are able to do is add them together. Like, there is no way to do, like, if tolerance is this or that, like, no, only addition. So, like, these guys, basically, what they need to do is they need to trust the protocol that it's gonna generally deal with the tolerance in an acceptable manner, but it's gonna be the same for everyone. So, yes?
Couldn't you make the slippage tolerance public and only the rest of the trade secret?
You could. Then the problem would be that you would probably land in your own batch with no one else. Like, what Penumbra does is rather they just have the public rules for setting the tolerance, so you just accept them. I guess what you could do is do like two different pools, like low tolerance and high tolerance pool, so you can choose one of the two, but like setting very non-default probably would land you in your own batch. Right, so so this is Penumbra, and now one slide about us, or maybe two, I don't remember. So what we do, like a revolution, is we reveal everything. I mean, I guess Michał can be really surprised because he got out of the paper and like entirely different thing written in the paper. But right now,
Big revelation.
yeah, the idea is to actually reveal everything on trade, because one step back here again, like here there is this elusive thing that, well, since we're getting batched together with other guys, like something is revealed, but like actually our entire intent is never fully revealed. I mean, the only thing which is revealed is the aggregate. So like if I was selling half ETH and someone else was selling 1 ETH, then like only the fact that generally 1.5 if was being sold is gonna be ever revealed. So like there is this some privacy here which I find quite elusive, because this kind of privacy matters the most for the trades which are big, which will never be hidden by the other guys, because you would need to wait for the batch quite long. So I mean, it's pretty hard to capture the benefits of this additional privacy. Yeah.
Practically, you can just split big trades into multiple small trades, right?
Right.
Like big whales do anyway. Like if you wanna
Sure, but like
a meal.
if you're splitting anyway, you shouldn't care much about whether this split will be, the part of the split will be hidden together with some other guy's trade or not. I mean, if you're splitting, you're providing your own privacy, like yourself, kind of, right? Since everything originates from the shielder, so there is.
In comparison to other designs.
Yeah. I mean, like, if you don't split, this is not gonna help you, and if you split, you actually don't need this help, I guess. And there is a downside, which is this tolerance problem that I just talked about. So right now, for us, it seems that actually this is not a perfect trade-off. So we're exploring a different trade-off, which is that we're revealing everything on trade, but we have the concept called reveal condition. So now a guy can send the order to the system, let's say, and the order, well, it's something like usually sell X tokens A for price B for B at price P, but it's encrypted and it has a public reveal condition. This, like the simplest reveal condition is reveal when the price of this assets matches this value. So this is like the reveal condition which you would want to have if you want to have something like execution on reveal. So basically, if the current price of a given token is $1 and I want to sell it for $2, like probably I want to put it as a reveal condition that like I want this order to be private until the price actually matches my execute price. So this guy send it to the system. Then again, similarly, and as in the design before, there is this decryption oracle which watches at all times, and whenever something qualifies for decryption, they just decrypt it, and then it goes to the individual trades goes to the open exchange protocol, which is a mix of Dutch auction and the order book. I mean, you can think about it as a Dutch auction, but actually, since the system is running possibly dozens, if not hundreds, of different Dutch auctions at different prices, this is actually an order book which is kind of alive and changes the prices like at every block. But yeah, this is a weird flavor of order book. And
do you match prices internally in the decryption oracle, or
sorry?
Do you match sorry, not prices, trades internally in the decryption oracle, or everything goes?
It's a good question. I mean, it seems more optimal to do that, although it's also complex. I mean, like when it comes to implementation. So yes, in the second version, we are planning to do that. It's like it's on our roadmap, definitely. But maybe interesting thing is like what could we want as a reveal condition? So the obvious one is the price. Like this concept of execution on reveal seems, I don't know.
Like splitting up a big order. And
Oh yes.
But didn't you say we want to abstract that away?
No,
This is
built into the system.
This is built to the system, and actually, I would claim that this is important for the reason I told a while ago, which is that in crypto there are still these manual traders, which are the guys that do not have a bot which is online at all times for the security reasons. So here you can create this iceberg order like today, and you can forget about it for a month, and it's gonna be there, and it's gonna be filled. To actually split the order, you either need a relayer which you actually trust, or well, your own DevOps employees, which will do it for you, I guess. And it's generally a complex problem.
Do you know what the cool reveal condition would be? Sell 10 billion ETH if there's an order willing to sell just after me. Like theoretically, you could do that.
What?
Program a sandwich attack as a reveal condition. Couldn't you?
I don't. Again.
We could only find a way to do math in this protocol that should protect us against math. Wouldn't that be cool?
It sounds like this could be done.
Again, the reveal condition says reveal this order if there is another order doing what?
Well, reveal it if there's another order in like the oracle or the system that's about to be traded. Like at least backgrounding, you could program this way, right?
Right.
I see, okay, a big order was just filled. I want to do the opposite direction.
That's correct. Backrunning, I mean, yeah, you can do backrunning with reveal conditions. It's a good point. Front running, no, we don't want front running with reveal conditions. I mean, like, definitely, whatever gets revealed first has a priority in trading over what was revealed later. But like when it comes to backrunning, yeah, that's a good idea. You can do backrunning with it. Like manual backrunning, kind of, you know, you can, this is like a lazy backrunning where you put all these orders and like shut down your computer and it's gonna work, hopefully.
I have a question. You said that you are giving priority to orders that have been decrypted first. Can you expand on that?
Yeah, it's a good, I mean, no, I think that was just a counter to ORES. Honestly, no, you don't need to do that. I mean, like, if the order gets decrypted, basically the Dutch auction on this order starts. It's not on the slide. I mean, I did not want to make it too complex, but you can have, I mean, you can have your own conditions for the Dutch auction. I mean, you can choose the length and the starting price and so on. So basically, whenever it's getting revealed, the auction starts, and it's up to the out of system actors like solvers to actually fill the auctions. I mean, there is like a concept of front running does not exist here because everything depends on the solvers, which are choosing the things to trade themselves. So like,
so builders can still front run.
Sorry?
The decrypted trades, right?
What does it mean front run in this?
So the decryption oracle like decrypts like one trade and then decrypts another, and like outputs like the first trade first, the second, but like then we need to create a block, right? So it's still
But like, if the only reasonable front running here is that I could prefer my order to be decrypted before your order gets decrypted. So the solvers will come to my order first before coming to your order if we are offering the same price. But generally, I don't think that, I mean, how we try to think about it is that I'm setting the Dutch auction so that it starts at such a price, then I will be super happy if someone just accepts the starting price of the Dutch auction, like winning on the lottery, right? Like that's why I don't think it's problematic. Yeah.
So what is the oracle? What is the decryption oracle? Like how can we envision
It's
checking the reveal condition?
Committee that shares the keys to the Elgamal encryption, and then the decryption basically is it's based on publishing parts of decryption which are connected on chain. And how does it look like checking the condition?
Yeah.
Well, the important thing is that it needs to be publicly verifiable that the condition occurs. I mean, so that the decryption oracle can be held accountable for not. I mean, we definitely don't want the decryption oracle to have a reasonable censorship, or like to have censorship in a way where it's not going to be seen. So Basically, these reveal conditions can be based either on a public oracles, which are on-chain, so that anyone can then say that, well, yeah, this condition actually occurs and they did not decrypt it, which means that they are not doing their job correctly and we should slash them. Or, well, based on the other orders, like they are in the system, so this is also publicly verifiable, based on whatever happens with the order. But I mean, basically, all the on-chain information, even historical, if we do the, V-layer integration, you can even base it on the history. Yeah, basically, whatever can be on-chain verifiable can be a reveal condition.
And so LGML keys for what?
For
What keys?
There is a single public key of the system, and the private counterpart for this key is shared among the committee.
Okay. So the weakest link will be the stake of such a decryption oracle, probably.
Yes, I mean, like they could collude to I guess, just peek into the orders for economic benefit. Although there are these arguments, I mean, also we have it on our roadmap, but generally there are these arguments that, I mean, this collusion is risky, because if we are together in this committee and you start doing something fishy and you share part of a secret with anyone, I can just take this part and say, well, this is part of our secret,
So
I should not own it, he shared it with me, so we should slash him.
What if they just use MPC?
Great question. Again, so yeah, this is generally, there is a branch of research which is called individual privacy, I think, or...
Crypto. I'm the author.
Are you? Okay.
Yeah.
You're working with Professor Dziubowski, right?
Yeah.
Right, so yeah, great question. So yes, we have somewhere on our roadmap to talk with you guys eventually, but honestly, yeah, I think this is...
So it's a nice topic, thank you for this.
It's definitely one of the potential use cases for this. As far as I know, I met, I think, your colleague on zkWarsaw a while ago, like a month ago. Yeah, I think so. Yeah, I think you don't have... I mean, we can talk a while after the presentation. Generally, this is the problem that we would like to have. I mean, like, the problem that knowledge of these orders can be utilized for economic benefits, which counts in hundreds of thousands of dollars. We would really like to be in the point where this is the problem. We're not at this point yet. So, like, we definitely want to have a usable product first, and then care about bulletproofing it. But yeah, we're aware of this problem. We're aware of you guys as well since recently. Also, yeah, then the question is, how feasible would this MPC actually be? I don't know. I guess depends what would they want to do with the secrets. Is it in a last slide? Yes, that was the last slide. Thank you. And also, there is a sign-up link to get to a regular pass to the verifiable summit by zkWarsaw. Right? Yeah. Was it correct? Even though it's incorrectly written here.
Any questions for Ada? If not, thank you so much, everyone, and we will continue an informal discussion over some drinks, I think, next door. Gorsha, do we know where we are?
Yeah.
Across? Yeah? Okay. So we will be heading that way. Thanks so much.
Thank you, everyone.